predicting products for replacement reactions. When you're looking for a replacement reaction, you're looking for an element and a compound, as you can see with magnesium and zinc chloride. And the element is able to push one of the pieces out of the compound. If it's a metal or hydrogen, it will push out the positive part, the front part, the cation in the compound. So what you see here is magnesium pushing out zinc. A pushes out my B. I'm going to get a new compound, AC, and then I'm going to get a new element, which is B. So you can see that these are referring to the different parts of this reaction. The way you decide whether the reaction actually occurs is by the position of, in this case, the two metals. For this reaction to occur, magnesium needs to be above zinc so that it is able to push it out. So this reaction would go. And if you are writing this, and what you get in the rest of these problems is, I would be starting with zinc or magnesium plus zinc chloride, and I have an arrow. And what I'm looking at is this metal is going to push the zinc out. And I need to check that magnesium is more active, is above zinc on the activity series. So these are our most active metals at the top. And then we go to the least active at the bottom. So because this can occur, I know that I'm going to get magnesium combined with chlorine, and I'm going to get zinc by itself as an element. Now, once I do that, I need to make sure that I've written correct formulas. So I'm going to look at magnesium and realize that because it is in group 2, it's a +2 ion, and because chlorine is in group 7, it is a -1 ion. And when I cross those charges, I'm going to need 2 chlorides to match up with the +2 charge of magnesium. And so now I have a balanced equation, which is what you see here. 1 magnesium on both sides, 1 zinc on both sides, and 2 chlorines on both sides. Now, on the other hand, had the reaction been written this way, I would have seen that zinc was below magnesium on the activity series, so that zinc could not push magnesium out of this compound. There would have been no reaction, and I would have just written NR for no reaction. I'm going to do a couple of other examples for you, and I'll use another example for a no reaction. For example, if I had cobalt plus zinc chloride, take a look at where cobalt is compared to zinc. Cobalt is here, it is below zinc. Cobalt cannot push zinc out of the compound, so this would be a no reaction. And then on the other hand, let me take iron plus hydrochloric acid. Okay, here's iron, and iron is going to be trying to push hydrogen out of the compound. Well, iron is quite a bit above hydrogen here, and yes, this reaction will occur. So we know we're going to get iron chloride, and we're going to get hydrogen. We need to look at the formulas for both of those. At the bottom, I've got some hints that you can use to deal with the iron, because iron is not a group metal. Iron is a transition metal, and so I have common charges, and iron is commonly a +2 ion. So if iron is +2, we should know that chlorine is -1, so it's going to take us 2 chlorides to match the two charges of iron. But we also need to look at hydrogen, and hydrogen's an element, and it is one of the 7 diatomic elements, so we need to write hydrogen as H2. Now we can balance the equation, and what you should see in balancing the equation is that you're going to need 2 HCl's to do this. So the equation for this is iron plus 2 HCl's. We're going to get iron chloride and hydrogen, and that's our balanced equation. Now I do want to note that when you come up with your products, you need to make sure that you write correct formulas. For example, when you come to this one down here, you're going to put H and Cl together, and they are a +1 and a -1 ion. Hydrogen is in group 1 and chlorine is in group 7. I keep putting too many ones there, sorry. Chlorine's in group 7. So make sure you write correct formulas. Also, let me mention something about the 2 activity series. This is the activity series for metals and hydrogen. Everything above hydrogen can push hydrogen out of an acid. So all of these metals, all these elements will react with hydrogen, which includes lead. And that's always been a problem when there's been lead soldering in water pipes, because if the water is slightly acidic, it can what we call leach, or the lead will react with the hydrogen in water and lead ions can get in the water, and that's a bad thing. Everything below hydrogen will not react with acids, and also everything above magnesium, or magnesium and up, can react with water. Magnesium reacts with hot water, sodium, and the rest of them will react with water at room temperature. On the other hand, I also have a non-metals activity series, and for example, if you had sodium chloride plus fluorine, because fluorine is above chlorine, it could push chlorine out of the compound, and then we have to balance this equation also. But that reaction would occur, whereas the reverse reaction would not occur because chlorine is less active and cannot push fluorine out of the compound. So I hope this helps you go through the worksheet. Again, the element is going to be trying to push in every case here is going to be trying to push the positive ion out of the compound. We have one where you're going to be working on the negative ion and try to decide if that occurs. But for the most part, you're going to be working with the positive ion, pushing things out. So I hope this helps. I suppose you can go through parts of this, review it, but see if you can get these to work out. Make sure that you write correct formulas and that you then balance the equation. And just check to make sure that the element is above what it's pushing out.